Hello students, welcome once again. In this video, we are going to study about stability studies. So before we begin with our videos, please like, share, subscribe and also press the bell icon for upcoming videos. So let us first understand what is stability. So it can be defined as the study of the extent to which the properties of drug substance or drug product remain within specified limit at certain temperature. Properties may be physical, chemical, microbiological, then toxicological or performance properties such as disintegration and dissolution. Or the USP defines the stability of pharmaceutical product as extent to which product retains within specified limit and throughout its period of storage and use, that is its shelf life, the same properties and characteristic that is it possessed at the time of its manufacturer. Then, stability studies ensure the maintenance of products' quality, safety, and efficacy throughout the shelf life are considered as prerequisite for the acceptance and approval of any pharmaceutical product. Now let's talk about importance of stability studies. So, stability study is important for development of optimum formulation, that is pre-formulation studies. Then it is also study to find the optimum storage condition, that is temperature to which it has to be stored, effect of light, humidity, etc. Then selecting the proper container for dispensing. So whether glass or plastic or clear or opaque, okay, a cap liner, etc. What type of container has to be selected, that can be concluded with the help of stability studies. Then it is also helpful for predicting the shelf life of the drug. Then stability studies are also important for anticipating drug excipients interaction. Then it is also done for stabilization of drugs against degradation. Then the next one is stability studies provide evidence as to how the quality of the drug product varies with time. Then determines container closure system suitability. Then stability studies assure to patient that drug is safe, and also stability study is legal requirement to provide document or data. Further, stability studies are also essential to protect the reputation of the manufacturer, then to provide a database, and to verify that no change has been introduced in the formulation or manufacturing process that can adversely affect the stability of the product. So for these purposes, our stability studies are very important. Then coming to next one, kinetic principles. So let's start with the definition. Drug kinetic, so it is defined as how drug changes with time, that is study of rate of change. Many drugs are not chemically stable, and the principle of chemical kinetics are used to predict the time span for which a drug, that is pure or formulation, will maintain its therapeutic effectiveness or efficacy at a specified temperature. Then kinetic study also applies to stability, then incompatibility, dissolution, absorption, distribution, also drug action at molecular level, and as well as elimination process. So importance of kinetic study. So kinetic study is essential in order to determine first one, that is stability of drug or half-life of drug, that is defined as time necessary for a drug to decay to its half-life or 50% concentration. Then next one is shelf life, defined as the time required for a drug to decay to 90% of its original concentration and to determine the expiration date. So for this purpose, kinetic study can be helpful. Now let us study about rate and order of reaction. So the velocity with which a reaction or process occur is called as its rate. Then the concentration of drug which influences the rate of reaction or process is called its order of reaction. So consider the following reaction, that is drug A, is going to get converted to drug B. Then the rate of forward reaction is expressed by minus dA by dt. As the reaction proceeds, the concentration of drug B increases and rate of reaction can be expressed by minus dB by dt. Then further, if C is the concentration of drug A, as it changes to B, can be described by expression as a function of time t, that is dC by dt is equal to minus kC to n, where k is equal to rate constant, n is equal to order of reaction. If n is equal to 0, then it is 0 order kinetics, and if n is equal to 1, then it's first order kinetics. In order of reaction, the number of concentration that determines rate and the way in which the concentration of reactant influences the rate. According to law of mass action, the rate of reaction is proportional to the molecular concentration of a reactants, each raised to power equal to number of molecules undergoing reaction. For example, AA plus BB giving a product. Then rate is directly proportional to AA and BB. Therefore, rate is equal to KAA dot BB. So, order of reaction is equal to sum of exponents, that is order of A is equal to A and order of B is equal to B. Then overall order is equal to A plus B. Now, we'll understand more clearly with the help of this example. Here you can see CH3COO C2H5, that is ethyl acetate, plus NaOH, that is sodium hydroxide, gives CH3COONA, that is sodium acetate, plus C2H5OH, that is ethanol. So rate of reaction is proportional to ethyl acetate and sodium hydroxide. Therefore, K CH3COO C2H5 raised to 1 and NaOH raised to 1 is equal to 1 plus 1. So rate of reaction is nothing but 2. And the constant K appearing in the rate law associates with single step reaction is called as specific rate constant for that reaction. Any change in condition of the reaction, for example in temperature or solvent, or slight change in one of the reacting species, will lead to rate law having different value for K. Now let's look at zero order reaction. Zero order reaction is also known as constant rate process. When the reaction is independent of concentration of reacting substance, it depends on power of reactants. That is, rate is equal to Ka raised to 0 B raised to 0. That is 0 plus 0 is equal to 0. In this, the limiting factor is something other than concentration. Example, solubility. So, in case of solubility, the amount of drug that is in the solution undergoes degradation. That is minus dA upon dt is equal to K raised to 0. On integrating the equation, integration of dA is equal to minus K0 integration dt. Therefore, 80 minus A0 is equal to minus K0t. Therefore, 80 is equal to A0 minus K0 t. So, this is zero order reaction. Moving further, first order reaction. So, these are the reaction whose rate is directly proportional to concentration of the drug undergoing reaction, that is, greater the concentration, faster the reaction. It follows linear kinetics, that is dC upon dt is equal to minus kc, where k is equal to first order rate constant per hour. Rearranging the equation, we can write dC upon dt is equal to minus kc can be written as dC upon c is equal to minus k dt. Moving further, so integrating the above equation, so we get dc by c is equal to integration of minus k dt. So integration of c minus integration of c0 is equal to minus kt. So integration of c is equal to integration of c0 minus kt, right? Both are one and the same. So in terms of log, it can be written as log c is equal to log c0 minus kt 2.303. So it can be reframed as k is equal to 2.303 upon t log c0 upon c. So this is first order reaction. Now coming to last one, that is second order reaction. So now second order reaction, here the rate of reaction depends on first power of concentration of two molecules, that is bimolecular. The reaction is said to be second order. Here the rate of reaction depends on both reactant's power raised to 1. Rate of decomposition of reactant A is equal to rate of decomposition of reactant B. Here it can be represented as K is equal to 2.303 T A minus B log of B in bracket A minus X upon A in bracket B minus X. So this is all about second order reaction. Thank you.